Hi, this is Dr. Frederick. This is just a mini lecture on type 1 and type 2 errors. When we're doing hypothesis testing, we're trying to evaluate our research hypothesis. Our research hypothesis is the one that we're interested in. Usually we believe that two populations are different. Perhaps we think that one method is better than another method. The way that we evaluate our research hypothesis is to set up a null hypothesis, which says that the populations are the same, or that one method is the same as another. And then we sample from the populations, compare means, for example, and then make a decision about the null hypothesis. And if there's a big enough difference in our sample means or in whatever statistic we're evaluating, then we'll say that the evidence suggests that the null hypothesis is false. If, on the other hand, from our samples we don't see very much difference, we'll say, well, I cannot reject the null hypothesis, so I'm going to conclude that there's no difference between the populations. Here's the point: we never know what's really true. The reason we use statistics in the first place is because we never know what is really true. It's too hard. We can't look at an entire population all at once and compare it to another population for many, many reasons. But this is why statistics were invented, is to evaluate what is true by making inferences or making decisions about what might be true, but knowing that we might be wrong. And so we recognize that when we make a decision, sometimes we'll be right, but sometimes we'll be wrong. And we never know when we're going to be wrong, because we never know what the truth is. So if you look at this table here, we say we have two columns here that concern what is true. And what might be true is that the null hypothesis is true, that there really is no difference between two populations. Or what might be true is that the null hypothesis is false, that there really is a difference between populations. Based on the samples that we have, based on the statistics that we evaluate, we're going to make a decision. That's over here in row 1 and row 2. In row 1, we reject the null hypothesis and say there is a difference. And in the second row, we say that there really is no difference, and we fail to reject the null hypothesis. And so there's 4 different outcomes. And 2 of the outcomes were correct. When we reject the null hypothesis and it's false, we have this blank square here. There's no error there. And when we fail to reject the null hypothesis and it's true, we also make no error. But on a couple of occasions we make errors. And one is when the null hypothesis is really true, when there really is no difference. We reject the null hypothesis and we're wrong. And we call this the first type of error, that we can make a type 1 error. On the other hand, there could be that there really is a difference in the population, but we didn't take enough samples, or we just had a bad random sample that didn't show us what was true. And that's the second type of error that you can make, which is that you fail to reject the null hypothesis when in fact it is false. Okay, so once again, there's a couple types of errors that you can make. And the reason that you can never know that you're making this error is that you don't know what is true in the populations. The way that we try to minimize our errors is to repeat experiments and to take different samples and to continue to evaluate it.